And here we go. We have liftoff.
Propulsion continues to be nominal.
R68 chamber pressure looks good.
Following up. Roger, roll, planet.
Water towers fly! Yes!
Tango down to nominal.
Flight downside FD off. Bring in FD off. Off. It's orange!
145! Oh my god! Oh my god!
Decollage.
What is it?
Put that in the big bag,
343 unfolds to go.
Indeed.
We rise together, back to the moon and beyond.
This methane will be igniting the flare, correct?
Yikes. You dead? Sure. We don't need any more of these.
We meet once again here as you take a live look at Space Launch Complex 40 at the Cape Canaveral Space Force Station, where the Falcon 9 is going to try once again to launch 22 Starlink V2 mini satellites on the Starlink 10-2 mission. I am Sawyer Rosenstein. I will be your host for this attempt, which hopefully will go off on time. And the T0 for today is 4:31 p.m. Eastern Time, a little over 52 minutes from now. After yesterday's weather scrub, you could see things looking still a little bit on the cloudy side today, but we have a chance, and we'll talk more about that, especially with my fantastic co-hosts here. So, we will start with Trevor. How's it going, Trevor?
I'm doing well. I'm really hoping we get to see this rocket take off today, given the weather is looking way better, given yesterday was 15% go for the window, and today it's between 30 and 70% go, so let's cross our fingers.
Oh, it is certainly crossed and ready to go. And once again, braving it out, joining us in the field is Julia Bergeron. Julia, how's it going?
It is going wonderful. Good afternoon, Sawyer. I am where I was yesterday at Marina Park. It is, well, as we said, a bit cloudy. Clouds are kind of normal. As a Floridian, I'm just crossing my fingers we don't have any afternoon storms pop up, but I am looking forward to today's launch because it's been, about 6 days since the last one, and that's a long time.
You are not kidding. I mean, even the camera there was like, whoa, wait a minute, it's been that long? It's got to get ready just like we do. And of course, we have our fantastic field crew today manning, or should I say crewing the cameras, excuse me, is D. So shout out to D in the field, operating all of our stream cameras from the field there today. So we've got some excitement there, and the person that will help bring you all of these fantastic camera feeds behind the scenes is Jay Keegan. So we've got a great team assembled for you today for this stream, and let's hope that it goes. So let's start things off. Trevor, can you kind of give us a rundown of the mission? Once you are unmuted.
Oops, sorry about that. So yeah, this is the Starlink Group 10-2 mission, as you can see in the top left. We are just about 50 minutes away from liftoff, which will be at 4:30 p.m. local or 8:30 p.m. UTC. This will bring 22 Starlink V2 mini satellites into SpaceX's Starlink Shell 10, which is at 53 degrees, probably somewhere on the order of 530 kilometer circular orbit. Also, as the name implies, this will be the second mission to that shell. The Starlink Group 10-1 launched just about a week ago, and that was the first Starlink Group 10 mission. And this continues while SpaceX is also launching the Starlink Group 8 missions from Vandenberg. Then also, I believe next week we'll have the Starlink Group 9 mission. So lots of Starlink missions coming up with very confusing naming schemes. The booster on today's flight is B-1073, flying for its 16th time. The booster flew 33 days ago and has supported SES-22, the Ice Space Mission 1, Amazonas 6, CRS-27, Bandwagon 1, and then 10 Starlink missions. Following stage separation, the booster will perform its usual 2 burns for a soft landing attempt on Just Read the Instructions, which was tugged downrange by Signet Warhorse III, if I remember correctly, and the fairings will both be recovered by Doug. One other thing I did want to clarify from earlier is yes, the 45th Weather Squadron's forecast says the weather goes from 70 to 30% probability of violation for today's launch. So what that range means and why I gave it earlier is at the start of the window, the weather is 30% go, and then later in the window, the weather improves to being 70% go. So that's the reason I gave that range earlier.
There you go. And along those lines, Julia, can you kind of talk about yesterday's weather? Because it was a little bit crazy and how it compares to today.
Well, yesterday's weather gave our camera operators a bit of a challenge because they were under a phase 2 lightning warning. So once we are under any sort of phase lightning warning, it means we cannot go outside when we are on the installation. So on that note, basically being surrounded by weather and unstable weather means a bunch of different things could happen as far as violations go for weather. And one of those, besides lightning, would be like the thick cloud rule. And not only does that pertain to the area around where we launch, but downrange, and that also works for our at-sea weather.
Right, that is true. It seems weird. It's like, wait a minute, they would delay a launch because of clouds? There is a reasoning behind it, and that is that some of those clouds have the potential to form lightning, which could strike the rocket, and as we saw from Apollo 12, could be quite dangerous, as I don't believe there is an SAE to aux switch on Falcon 9. What we do have, though, is an amazing amount of generous support already. Crispy, and that's 1341, not Crispy Bacon, who we saw during the cooking stream, gifting 50 Red Team memberships. Holy smokes. Thank you so much for doing that. That is extremely amazing and impressive and appreciated. And anyone who got one of those, please make sure to give them a thank you. And hopefully you'll enjoy all of the fantastic perks that you get as a member, including some unique videos, photos as well. And remember those live streams with the bacon? Any member could have joined that. So another one of the beautiful perks is random bacon and random driving streams too. You never know. So thank you. Nolan, thank you as well for gifting a Red Team membership. Every gift is always appreciated, especially getting more people access who may not be able to. So that's nice. Mateus, thank you for gifting a Red Team membership. Aerospace Rocketry saying, greatest job all. We're YouTube dedicated to building scale high power rockets like the Falcon 9. Ain't that the truth? And Stefan also saying, thank you for the great content and the 4 towers. Oh, the 4 towers will never go away. And musical wolves are the question. I'll pose this one over to you, Trevor. Are V2 minis compatible with the V2 Starship?
No. So the V2 mini satellites are specially designed for Falcon 9. Even though they have mini in the name, they're really not that small, right? They mass on the order of 800 kilograms. And that's way higher than the V1, which was like 260 kilograms or so per satellite. But anyway, they're designed to be launched on the Falcon 9, and that means SpaceX knows exactly how large the fairing diameter is and how much performance they have out of the vehicle. So they made them to that size. However, for Starship, they're going to have a substantially larger payload volume that they can take up. So therefore, the satellites for Starship are going to be a lot bigger. So I guess in theory, SpaceX probably could launch V2 minis on Starship if they really wanted to, but it wouldn't really make that much sense since they have an entire other line which will be launched on Starship. And at this point, we're thinking that Starship will probably be launching V3 Starlink satellites and not V2, but that obviously is still a little bit out as SpaceX makes Starship operational.
And I know we don't know this exactly, but kind of just to clarify, I think what Music Wolves is also asking is, will those be compatible with the whichever Starlinks that Starship ends up launching? So
Ah,
would a V2 Mini, say, be able to do the laser connection with a Starship
yes,
V2 or
yes.
V3?
Yeah, sorry about that, Music Wolves. I misinterpreted you. Yes, that will be the case. So just like we're seeing the V1.5 satellites are able to communicate with the V2 mini satellites through those laser links, the same will be true for V2 mini and whatever the satellites that Starship end up launching are. So sorry about misinterpreting that, but yes, the entire constellation is compatible with one another.
I think part of that was on me. I don't know if I read the full question out, but yes. Thank you, Musical Wolves. Wanted to make sure we gave you a correct answer to your question. Now, Julia, we don't have Max on this stream, so this is the best part. Mockspace asking, W Nozzle, yay or nay? And also asking, will Falcon 9 ever have new landing legs?
Oh, well, as far as stubby nozzle, nay, not this mission. It is not required. Um, will Falcon 9 ever have new landing legs? Well, actually, Falcon 9 does have upgraded landing legs, although I'm not sure entirely when they started doing it or if they have retrofit some of the more mature boosters, shall we say. But it was mentioned that the upgrade actually enables the boosters to kind of self-stabilize on the deck of the drone ships, which I suppose would allow them to possibly be able to run the octograbber out underneath before they even board, as well as help keep it stable in rougher seas. Neat, huh?
Oh, it's so cool. And for those who don't know, the Octograbber is literally this little robotic thing that goes out and grabs onto Falcon 9 and keeps it secure on the deck for the ride back to the Port Canaveral area. It's so cool.
It grabs the octa web. So fancy that.
Oh, I wonder how they came up with the name then.
Go figure.
uh, let's see here. We've got one from, I believe that's Psychosocial. Uh, and I want your opinion, Julia, while I still have you, saying, is it just me, or does every Falcon 9 launch still feel special for the reason that it is normal, quote unquote, now?
Well, every launch is special. I I think. I mean, every launch. Well, I don't know what's exactly special about this one, Sawyer. As far as I don't think we have any new records per se, but they're all still special. We as locals love seeing them. We still hear some locals say, "Is there a shuttle going up today?" Don't laugh. It's a real thing, and the answer is yes, of course, there's a rocket going up today. And more often than not, if there isn't a rocket going up, then there's a rocket coming back to port. So it's just kind of part of the norm and it's special to us here. And I can't imagine living anywhere else.
Yeah, it never gets old, and I think it's safe to say that every launch is slightly different. I always like to say this isn't your ordinary Starlink launch, which of course it continues to not be your ordinary Starlink launches here with between the weather delays and also now with the uh, Group 10 missions going up. Uh, this will be the 61st Falcon launch of this year. So it's still. I find the little special things, but when you see the launch and you hear the launch and you feel the launch, it doesn't ever get old. I always tell people if I ever say, "Oh, that was kind of boring," or "I'm getting tired of it," check me into a hospital immediately because something is wrong. Uh, Let's see. Here's an interesting one. Trevor, gonna put your math skills to the test here.
Oh gosh.
Ninja Guy Dan asking, does SpaceX use any electronic load cells to detect the exact weight of a vehicle on the pad? Or do they calculate the weight of the vehicle, its contents, and the frost formation? How do those calculations work?
Um, that's a good question that I don't think we really have any good answers to. I would imagine on the pad, they probably don't have that many sensors for stuff like that because I would conjecture that the mass differences that you'll see between launches is going to be very minor compared to the mass of the entire stack. Um, right, the vast majority of Falcon's mass is going to be in propellant, regardless of how much payload it has or how much ice is on the vehicle or whatnot. Um, but yeah, that's an interesting question. I'm sure SpaceX does keep track of the masses. I mean, they have to keep track of the masses of everything, but I would imagine that's done kind of outside of the pad and as part of refurbishment or whatnot. That's an interesting question, though.
Ooh,
It really
ooh, ooh.
is.
I have an answer though. I
Ooh,
mean,
go for it.
maybe not for modern day rockets, but fun fact, if you visit Launch Complex 26 at Cape Canaveral Space Force Station and you go inside of the blockhouse, there is actually a scale. And that scale leads to the launch pad, and that is how they knew how much fuel was on board by physically weighing the fuel as it was going into the rocket. So, such a thing did exist, and do we know exactly how that exists for Falcon or any of the modern rockets? Probably not, but I believe it would be somewhere along the line of a math equation and knowing how much fuel is being sent in, how much that fuel should weigh, added to what the known variables are. And maybe there is still a scale at some of those pads because Launch Complex 40 was a Titan pad after all.
There you go. Can you guess that somebody is a volunteer docent at the local museum? But that's so cool. On the older pads to still be able to have that. What should also be cool, hopefully soon, is the rocket. Let's take a look at the countdown and where we are at this point. We will hopefully hear that they are go for propellant load sooner than later. And as of right now, it appears, sorry to break this to you now, Jay, but liftoff now targeted for 4:49 p.m. Eastern Time, just announced on the SpaceX website. So we have a little bit of time now. We'll update that clock for you in just a second here. Um, but once we do get the go for fueling, then we will hopefully see things getting frosty. That go no go poll happening at T minus 38 minutes, probably why we just saw the update now on that. So 54 minutes to go. But then once they do go into prop load, there is the update on the website there, 4:49. And again, it is worth noting, you can see there they have backup opportunities available until 8:19 p.m. Eastern Time. So plenty of time. And we'll see. We'll see if we end up chilling in the flame trench waiting for the launch, or we continue here. But for now, we will wait for hopefully that fueling to begin, which is the RP1, rocket propellant 1, the refined form kerosene in that first stage, along with the liquid oxygen into the first stage. And stage 2 also gets its RP1 load started at T minus 35 minutes. It only does RP1 though, and waits until T minus 16 minutes to start loading liquid oxygen. You will note there is a 4-minute gap though between when the RP1 finishes loading and the LOX begins on that second stage, as signified by what we call the best vent, or the T minus 20 minute 20-second purge. Let's continue on here with your questions in the meantime, and I think this is the perfect time to ask this question to Julia here. Rankley asking, with a heavy forecasted named storm season predicted, do you think weather could be the overall reason if SpaceX doesn't reach their launch goal this year?
Yeah, that's a very valid question. So, as I mentioned at the beginning of our stream, it has been 6 days. And I don't think it's exactly a coincidence that we are now launching to the northeast. Although our storms do tend to come from the southeast, they ultimately also end up toward the northeast. But I think this will buy us a little bit of time as far as being able to launch and try and keep that cadence. I think that will be one of SpaceX's biggest challenges is to navigate a what already feels like volatile tropical season and trying not to push the boundaries too much um, along the way with the fleet.
Right, and a reminder, the goal this year was 144 plus the 4 that they were short of their goal last year, so 148 launches. As we mentioned, we are already into the 60s at this point with, I believe, 61 launches so far this year. So there's still a chance,
Okay.
but yeah, as we've seen, this
We'll do the
launch
math.
has
Do that. We're halfway through June. We're halfway through June. Take this number times 2, and are we at 142? No.
uh
I really honestly hope we can get that far, but no, we'd be at one in the 120s. Let's just put it that way.
still
But there's
impressive.
also non-tropical season.
True, they can catch up there for sure, but it's worth noting, Alex in the back channel pointing out that previously for 2022, their goal was 60 launches in a year. And here we are just 2 years later, and we're at 61 with this launch in June. So they've already made amazing
You know,
strides in terms of flight cadence.
and
The
that
other
kind of
thing that
puts that into perspective how fast that we've become faster at launching, but also that a lot of the boosters that are being reused right now to achieve this cadence are about 2 years old as well.
Amazing. What were you saying there, Trevor, too?
I mean, the one other thing that's important to keep in mind is SpaceX has had a few slower months this year. And if you look at their maximum theoretical capacity, right, they've demonstrated the ability to get, depending on if you're in UTC time or local time, 13 or 14 launches in a month. So if you assume that later in the year, when weather is better, they're able to hit that stride, which probably quicker than that, since they'll have made even more improvements. The getting in the 130 and 140 launches is definitely not conceivable, especially if you include Starship, which, to be fair, SpaceX's 148 goal does not include Starship, but still, the cadence that we're seeing is extraordinarily impressive.
It's unbelievably impressive. And you pointed out that, it's a lot different during the end of hurricane season, which ends in November. But the other thing to note is that over the winter, we saw so many of these going southeast. But with all the potential for disturbances and things, interesting now to see the trajectory change, which, Trevor, this one is going northeast, right?
Yes, so this is the first Starlink mission in a long time that we've seen go to the north as opposed to the south. So it's
Second, but
on
yeah.
that, sorry, second, yeah, Starlink Group 10-1. Um, so most of the launches have been on the descending node, like all of the Group 6 missions, and I think a lot of the Group 5 and maybe even 4 ones as well. Um, but for some reason, they've decided to switch it up. This is probably because of weather, where they're just going to launch the direction that makes the most sense with current weather conditions. But that's something that we'll have to wait and see. But in this graphic, you can see the first stage recovery zone, that kind of um, shaded area downrange. That's where stage 1 is going to land. Again, on just read the instructions. And then also roughly in that area is where both fairings will be recovered. So they have that marine keep out zone just to make sure that the booster doesn't land on someone's boat or, if it goes off course or whatnot. So all about keeping the public safe as always.
Exactly. Yeah, so you've got the drone ship ready about 600-ish kilometers downrange. The fairings, which will also be recovered, about 700-ish kilometers downrange. So kind of between those top two upper leftmost points. And then, as Jay was also showing there, you have the second stage potential debris for the reentry of said second stage, which this time takes us around the southern part of Australia, kind of near New Zealand there as well, which don't forget Rocket Lab also launching out of New Zealand there too. And want to clarify, forgot about the one random Group 8 mission, 8-5, that also flew on that northeasterly trajectory. So this is the third. Definitely not the last for a while, it seems like at this point.
So many Starlink missions.
Which, you know what? That brings me to a question that I saw. If I can remember where I put the question. Let's see. It was from Falcon Drago. Says, not sure if anyone has asked this question, but why so many Starlink satellites and how many more are they sending up, Trevor?
Yeah, this is a good question. So, the whole idea of Starlink is to have satellites in low orbits. You can get latency, so you can minimize latency. So, if you look at the geostationary satellite constellations for internet, like Viasat or some of the others, right? Those satellites are about 35,000 kilometers or so above the Earth's surface, and the speed of light is only so fast. So the fastest latency you can really get out of those geostationary constellations is about half a second of latency, which is, it may not sound like a lot, but it really makes for a lot of what we do on the internet to not be possible, right? You've probably noticed if you're on an airplane when you're using one of those constellations, everything just feels really slow. You can't really send messages that quickly. You certainly can't join a voice call or anything like that. And that's not because of the speed. It's just because of latency. So Starlink is going to bring all of those satellites down to about a few hundred kilometers above the Earth's surface as opposed to a few tens of thousands. And because the speed of light is constant, that means they're able to get substantially less latency. So Starlink has about 20 to 50 milliseconds of latency. They've been working on decreasing that, whereas again, those geostationary satellite constellations have about 500 milliseconds. So it's over an order of magnitude better. And the downside of bringing them way lower, and why this is a very, very hard problem, is that it means that each satellite can see a much, much smaller portion of the Earth's surface. So whereas in geostationary orbit, you can basically see, around a little under half of the Earth's surface at once, maybe like a third. In low Earth orbit, you're seeing, maybe a thousandth of it, or probably even less. So you need many, many more satellites to be able to have coverage anywhere you are on the Earth's surface. So that's why there needs to be so many satellites. And that SpaceX first achieved with the View 1 Shell 1 constellation, where they achieved service anywhere on the Earth's surface between like about positive 55 degrees and negative 55 degrees, which is about 80% of the Earth's surface. And as they've been launching more satellites, they've just been expanding the amount of capacity they have on orbit. So that's why we're seeing them launch so many more, because they're just drastically reducing the amount of clients they're able to have in this constellation. And they're going to continue doing this they have permits, or they've applied for permits for up to something on the order of 42,000 Starlink satellites. It's very unclear how many of those they'll actually end up launching, especially as Starship comes online and they're making these more and more powerful satellites. But that's the whole idea. Starlink is in a very low orbit, which is what allows it to be actually usable.
Exactly. And they're talking about increasing the bandwidth between all these satellites too, with all these upgrades to the satellites and their network. It's crazy. So with that lower latency, I'm going to need a new excuse as to why I'm so terrible at Fortnite. Anyway, I think that silence is quite appropriate for that terrible joke. Let's get to another question here then. Julie, I'll put this one to you. Rankley is asking, are they still exploring RTLSs for Starlinks? Do we know?
We don't know that answer actually. That seemed like such a hot topic not all that long ago, and then it just kind of disappeared. I do believe they applied for and were granted the license, so therefore the ability to explore that option. I don't know if we've just deemed that the fleet can indeed have a fast enough turnaround time that that is not necessary, or if that's something we're going to be exploring perhaps later in the year. Now, another thing is that SpaceX will be, although we don't know exactly where at the launch pads, but SpaceX will be having Vandenberg style return to launch site landing pads. And maybe that's when we're going to be looking for that happening. But my gut is telling me that the fleet can do what they need to do fast enough for them to be able to get a rocket ready at the pad and be ready to launch again. So maybe that's not a necessary option at this point.
That could be, again, you also have the concerns of, do you have enough propellant that you can still launch all 22, or is that going to cut back on the number of satellites you can launch, at which point, it kind of defeats the purpose of trying to get this super crazy increase in cadence to hit that 144/48 target for the end of the year. Let's see, we are coming up now on T minus 40 minutes, which means we are hopefully just 2 minutes away from the launch director hopefully verifying go for propellant load. Again, at last mentioned, the opening of this window was a 30% chance of go, improving to a 70% chance of go as the window continues to move on. So we shall see. We're going to keep an eye on it over the next couple of minutes, but I do want to thank Apocalypse Cow for the 5 gifted Red Team memberships. That is very much appreciated. Thank you. Now, it's a bit of a techie question as we wait for the, hopefully, to see them fueling and they load those super chilled propellants. Damien wants to know, Trevor, how do they super chill the propellants?
Yeah, so it's all done with liquid nitrogen, just like we see at Starbase. They have those, uh, well, what are they called? The pre-chillers, super chillers. For some reason, the exact name is escaping me right now. Where they
Subcooler?
just subcooler. Thank you. I don't know why I couldn't remember the name of that. Where they run liquid nitrogen through there to help cool down the liquid oxygen, and in the case of Starbase, liquid methane. Um, and that brings the temperature of those down while warming up the liquid nitrogen. And then the liquid nitrogen vaporizes and is vented overboard, and that's why we see all of the subcoolers venting. And then for the RP1 side, since you don't want to bring that down as cool as you do liquid oxygen, right? Liquid oxygen they bring down to about negative 210 centigrade, when RP1, I believe, is right around like, it's just a couple of centigrade, like right above the freezing point of water. Um, so you obviously don't want to bring your RP1 down all the way down to the temperature they have liquid oxygen, since that would make it be a solid. So that I would imagine they just do with, I don't know, maybe gaseous nitrogen or something, but I'm not sure how they'd subcool that one.
Yeah, and I do love the fun fact that Alex just pointed out in the back channel here that they have different names for the different vehicles. We've got the rhinos for Falcon, as opposed to the hippos that we're used to seeing over at Starbase. So I do like the different animal kingdom that they've got going on for super chilling propellants. Again, we should be in the middle of that poll, so hopefully in the next 2 minutes or so, we will see whether the rocket gets frosty or I get frosty as the clock then delays again. We shall see here. In the meantime, though, again, if they do give the go for propellant load, that will start with the first stage with RP1 and liquid oxygen. It will also begin with RP1 on the second stage, the liquid oxygen coming much later in the countdown at the T-minus 16-minute mark. Of course, following the best vent. That best vent, though, is going to have to wait, as we are not go for fueling for this particular portion of the window. That means they move to their next T0, which will be 5:07 p.m. Eastern Time. So we're going to have to wait just a little bit longer to see this bird fly. But hopefully it will fly, as mentioned, the forecast improving as the window goes on. So that's a good sign, at least. Hopefully, right?
Certainly
Any-
not a bad sign.
I
I
was going to
mean,
say, someone help cheer me up.
well, as I get out of the car and look around me and I think, "Oh, why?" I don't know why. I wish I knew the why, so I could learn from that. I don't know if it's just the type of clouds that are over the KSC Cape area right now, which, I mean, to be honest, I guess could form into anvil clouds, or maybe it's just that there's the potential of other clouds to the west. But I can only assume weather because I can't imagine that they aren't ready to fuel in that sense.
Right. Oh, I totally imagine they're ready for the fueling portion. It's just actually going ahead and doing it at this point. I'm keeping an eye as well on the weather channel that the Kennedy Space Center has and waiting to see if there's any portions that are in lightning warnings, and there are. They're all phase 1, but the KSE industrial area, Cape Central, Port Canaveral area, and the area around Sidco Park, where SpaceX does have one of their facilities still there, are all in phase 1 lightning warnings. Julia, can you kind of explain, being at the Cape there, what a difference is between a phase 1 and a phase 2?
Phase one is the potential is there. So basically, you need to be in a state of kind of wrapping up your projects so that you are at a halting point in case a phase two is activated. Phase two means that there is indeed lightning observed in the area, and we cannot lift a phase two warning until it's been 30 minutes since that lightning strike. So, um, yeah. So if they're in a phase one, it means whatever clouds I'm seeing have that potential to indeed exert themselves, shall we say, and and produce lightning. And if we do produce lightning, being in a fueling state would be a bad thing.
Yeah, that is a good point. Again, I hate to keep bringing up the same example, but the reason that we don't launch in certain conditions is because of Apollo 12 getting struck by lightning on the way up. So there was always that concern. It seems like it was a storm anyway. Soyuz just kind of goes, whenever. But it really is important. Julie, I think there was a really nice graphic that the 45th put out kind of explaining it. Do you mind just kind of running through the importance of those clouds real quick?
Absolutely. And I should probably, in that respect, pull my version up of it. But as you can see on this graphic, it explains the different cloud rules, whether it be an attack cloud rule, which that's kind of what I'm feeling is going on around here today, just judging by the look of the clouds. They're clouds that could have an anvil cloud start above. Another one of them is a lightning producing, hold on, thick cloud rule. That's the one that we were looking at yesterday, where although maybe there weren't lightning producing clouds at that moment, there were thick clouds that were coming into the downrange area, and those thick clouds are what can produce lightning, as we talked about Aries 1. as the rocket goes through there. And the bottom of the graphic, Sawyer, if you wanted to kind of talk about that one, I always think that's an interesting topic.
Absolutely. Jay, if you don't mind scrolling to the very bottom, they've got a cool explanation of the difference with just regular old lightning and rocket produced lightning. I love this. So you can see there, as it mentions, you lived in Florida, you're familiar with natural lightning, which, of course, is always a concern anyway, which is why you have the four towers surrounding it. um, but the concern is also the rocket triggered lightning. And a lot of that has to do with the electrical field and everything around it. You can see if that field is undisturbed, it's not really a big deal. If it becomes disturbed, like you see there during the actual launch, it can push that field apart. And once that field stretches out enough, you can actually trigger lightning just by the rocket going through it. As they talked about during Ares 1X, the tribo-electrification rule. They don't really use that term anymore, but tribo-electrification, great Scrabble word, and also the concern of why they don't want to launch into clouds. So, as much as it seems like, oh, why is there a cloud rule? Hopefully that explains it a little bit better. Thank you, Julie, and thank you, Jay, for pulling that up.
And I can attest that this is like the unsettled time of the day here in Florida, as Sawyer would know. This is a time of day where things just kind of happen out of nowhere because, well, the ground heated up all day long and winds change. And sometimes that means things start happening.
Yeah, especially mid to late afternoon. I mean, like I was saying before we went on air here, where I live, which is south of the Cape, it was absolutely gorgeous all morning, beautiful, sunny, nice day. And then about a half hour before we were scheduled to go live here, torrential downpours began. So, not like we've had any of those lately, like tens of inches of rain coming down per day, which is crazy. Let's get back to Falcon here and Starlink in particular. Trevor, I'll throw this one to you. Michael Sharon with a great question of how long does it take for a Starlink satellite to go operational? Because there seem to be around 1,000 missing per Alicia in This Week in Spaceflight, which is available now on the NSF YouTube channel if you want a really awesome update on everything that's happened this past week, explained in a really cool, awesome way.
Yeah, that is correct. So thankfully, Jonathan McDowell tracks all of this information for us. And if you guys don't know about Jonathan McDowell or don't follow him, honestly, probably the best follow you could possibly make in the space area because he just tracks every single thing and he is phenomenal. So he tracks all of the Starlink satellites, and you are correct that there are about 6,150 in orbit, and only about 5,200 of those are operational. Um, so it takes on the order of a few months for the Starlink satellites to become operational. The one thing that we're not entirely sure about is right, can easily measure how long it takes for the satellite to reach from initial deployment all the way up to when it's in its operational orbit, the circular 500-ish kilometer orbit, depending on the shell. However, what's less easy to know is when is SpaceX actually able to start including that satellite in the constellation? Because it's very possible that they're able to have that satellite become operational in the sense that it is being used in the constellation before the satellite has reached its operational orbit. So it's on the order of a few months, but we don't have the best idea of that, sadly, since SpaceX's management of the constellation is not public.
There we go. And then let's take some more questions here about the Starlinks. John asking, Trevor, are they planning on putting Starlinks in lunar orbit at all?
I'm sure eventually they will, but certainly not anytime soon.
I mean, yeah, there's always talk about it, especially with the Lunar Gateway program, although that's still a little ways away. But once they have that orbital station out there, it is a potential for communications, especially if the long-term goal is to set up a base on the moon and said orbital outpost.
Yeah, it just comes down to the whole talk is easy, execution is hard, and until there's a reason to have the constellation, there's no reason for SpaceX to start putting those up there.
We've got a really good question here from Jonathan Tucker, and I'll pose this one to you, Julia. They said, during all the time you've had cameras on these towers, have you actually seen them take a lightning strike? Julia, have you yourself seen a lightning strike at these pads?
Um, I have not personally seen it, but my cameras have seen it. We had cameras set up remotely at Launch Complex. Well, it was for Launch Complex 37 for a Delta Heavy. And indeed, lightning struck the tower not once, but twice. And due to the storms, our cameras were triggering at the time. So, yes, indeed. And you know what? I think Max caught one at 39A, and I take that back. I remember being hunkered down in the hut with Max and seeing lightning strike. That's the image that he captured. So, indeed, I have seen that live, and it's kind of terrifying, to be honest, because it's really loud when you're only a couple miles away from the pad.
Isn't that the truth? My
Yeah.
goodness. I
Those are the kind
believe.
of storms that are actually scary, y'all.
Uh huh. And we do have some cool prints, by the way. Shop.nasaspaceflight.com. Cough, cough. Of actual lightning strikes, one at McGregor and one that was near the launch pad for Artemis ahead of its launch. So you could see 39B and the lightning strike in there. So we have photos of it, and you can see them. We got a question here from Jake. Trevor, I'll put this one to you. While we were talking about the landing, they were wondering, how do the Falcon 9 landing legs actually work?
Ooh, that is a good question. So, it's a two-stage mechanism. So the first is there are latches that keep the leg attached to the vehicle. And then, so those latches are deployed first, and then once they're deployed, gravity can start pulling the legs down. But also, to make sure that the legs deploy fully, there's a helium pressure line that forces the hydraulic pistons out, causing the legs to go all the way down and then lock into place. And then once they're locked into place, the vehicle is able to successfully land on it.
And then, as mentioned earlier, Julia talking about the Octograbber being out there to help secure it after that. And then we've seen them fold the landing legs, we've seen them remove landing legs, things like that afterwards once they make it back to the port. Let's see here. We have 5 gifted memberships here from Ninja Decimator. Pew pew pew. For those who don't know the inside gag, it's something that Jack has been doing for a while with the name. In fact, during certain streams when Kevin is operating, he has a pew 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 sound effect. So, Ninja Decimator, thank you as always, though, for gifting those 5 Red Team memberships. I have a feeling a lot of people will now be saying pew 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 in chat. Let's see. Ooh, this is a really interesting one from Rankley. Julia, this one's aimed directly at you. They're asking, for Julia, if you could put cameras on Falcon 9, where would you put them?
Oh, wow. Huh. That's a good question. If I could put cameras on Falcon 9, where? Oh, man. I don't know what view I'd really honestly change that SpaceX already has. I can't think of. Wouldn't it be cool to have a view closer to the engines? But I know that cameras tend to not survive those views. That's why there is thermal protection down there. Um, if I could, oh gosh, how about following a fairing down just like we follow Starship down. That's one we don't get enough views of. I would say I would put a camera on the fairing and try to watch it come all the way down, parachute, and land in the ocean so that we can get a view of the ship coming to recover it.
Ooh. I mean, that's brilliant because we've seen some of the re-entry from inside of one of the fairing halves, but not the entire trip all the way down. And in terms of splashdown, most of the videos are still from the old days of when they owned Mystery and Mischief, which were ships with giant nets attached to them to try and catch the fairing halves, until eventually they realized this is not the best idea. They end up missing most of the time, and turns out they do fine floating in the water, so let's just land them in the water and have either Bob or Doug come by and scoop them up and bring them back, which is exactly what they do. And Doug is the one that will be hopefully doing that today, assuming we actually get this rocket off. As we are now at about the 39-minute mark, in 1 minute, they should begin the polling again for the go for propellant load. I won't even explain how the process works because every time I've done that so far, it has delayed a bit. So we'll explain it once fueling begins. How about that to be safe? Oh boy. This is a really interesting question. I know we don't officially know the answer to it yet, but what are your thoughts, Trevor? Will Starship be more resilient to weather, or do you think same rules kind of apply?
That is a good question. I think long term, it kind of has to be. Um, One advantage that Starship has over Falcon is it is a lot less fine. And what I mean by that is the ratio of the height to the width of the vehicle. And since Falcon is a very tall rocket for its diameter, that kind of makes it worse in weather since you can kind of have some weird torques applied, some weird torque applied to the vehicle, which is not exactly what you want, especially in the upper altitude wind shear. So my guess would be fundamentally Starship probably will be a little bit more resilient to weather. Um, However, it'll be very interesting to see how many of the rules are able to push long term. I know several years ago Elon posted on X saying uh, that they are planning or that Starship will be very resilient to like lightning strikes and whatnot. So all of the lightning rules that Julia and Sawyer were just mentioning may not be applicable to Starship once it's in its operational phase. But this is something that SpaceX is probably just going to have to learn as they fly the vehicle. You know, how much winds can it tolerate? How much can it get struck by lightning? Does that pose any risk to the mission? And this is something that's pretty standard in rockets, right? We've seen Rocket Lab, for another example, their wind criteria used to be a lot more conservative than they are now. Since now that they've launched 49 missions, they have a good idea of, you know, how much wind the GNC is able to overcome.
There we go. All right, we will see what happens here with the countdown now. Uh, let's see here. We have confirmation from SpaceX that they are going to go ahead and start loading up Falcon 9 with its propellants. Didn't jinx it this time, at least. I shouldn't have said that until the rocket's frosty. But we are getting official word at this point, and there it is, that all systems are looking good, and propellant load is about to begin for today's launch of 22 Starlink satellites from Florida. It does not give an update to the weather percentage, but hey, that's a good sign. They're actually going to begin the fueling process. So, hopefully they make it farther than yesterday. So for those who missed yesterday's fuel loading attempt, what actually happened there, Trevor?
Yeah, so yesterday SpaceX got into fuel loading where it was for basically the very end of the window, and whether they said upon fuel loading was 40% go for launch. And SpaceX got up to, but not including second stage liquid oxygen load. So they got through that T-minus 20-minute vent, and then at T-minus 16 minutes, when when liquid oxygen should have started loading onto second stage, we realized there wasn't any frost on the vehicle. So some of us or Alex in the back channel started thinking the launch was scrubbed. And then seconds later, we got confirmation from SpaceX that they had to stand down due to weather. So they got up to about the T-minus 16-minute mark yesterday before they realized the weather just was not going to be in good for launch, so they decided to call the scrub.
Yeah, let's hope that we actually see frost on that second stage as we get beyond the T-minus 20-minute, 20-second purge vent, whatever you want to call it. But at this point, we are now under the T-minus 35-minute mark, which means I think we can safely actually go over the timeline of events now. Hopefully. As you can see, we finally checked off that they are go for propellant load, and at this point, they should be starting to load the RP-1, Rocket Propellant 1, the refined form of kerosene, into the first stage, along with liquid oxygen, LOX, or as people hate it when I call it, LOXygen. And then on stage 2, they are starting with just the RP-1. That will load until T-minus 20 minutes and 20 seconds, when they will then chill down the lines to prepare for the liquid oxygen load before loading them, ironically, about 4 minutes later. I think that's 3 minutes and 20 seconds, if my math is right. Or no, it is 4 minutes and 20 seconds. That's the irony there. There we go. So all of that still to come. Of course, we have our cameras looking at the rocket, and we will hopefully start seeing that frost forming very shortly. Chris P, my goodness, already gifted 50 Red Team memberships, gifting another 50 Red Team memberships. I gotta find words. This is my job, is to have words here. Thank you. Is all I can say. I'm so grateful for you doing this. Again, I know there's a lot of people that can't support financially out there. Heck, people just watching that's support right there, liking that kind of stuff, telling the YouTube algorithm, hey, other people might enjoy this too, helps a lot. And then to be able to have these gifted memberships that people finally get a chance to see the membership perks, the behind the scenes videos, the photos that get posted, access to the random bacon live streams, all of that. Thank you, Chris P. You really are helping to grow the community with that, and we really appreciate it. I know I'm waxing on a long time, but 100 gifted memberships is absolutely above and beyond. All right, let's also hit Rankley's support here, which any support and all support is beyond appreciated here. Saying, I love all the great information. I always learn something new watching these streams. You guys are the best. Well, thank you. That's part of the goal, is to have some fun, to learn, and to watch rockets go brrr. That's the official onomatopoeia for rockets lifting off, right? Just brrr.
I think more roar, but okay. Burr.
It's more funny to see it spelled out B-R-R-R-R-R-T, but you're probably right, more of a roar.
You know, I just realized this is the first stream that I can actually say I have heard a rocket.
That is true, but this is gonna pale in comparison a little bit, but yeah.
Yeah, it is impressive in person for sure.
Let's see here. Here's a interesting question. And Julia, as someone who tracks the trajectory of launches and things like that to try and get some of those shots, Death Ruddles wants to know, is there a way to track the orbit of these launches? Say they're in the UK and always wonder if there's a chance to see a second stage burn.
Oh, well, There is, oh gosh, I haven't used it in a while though. There is a tool, and Sawyer, I'm going to need your help remembering that.
Flightclub.io.
Thank you. Flight Club. I haven't used it in a while, and I'm guilty of that. I'm somebody who likes to pick a location that I think is going to be scenic and then just kind of assess it. And I tend to not be the technical photographer, but you can use flightclub.io to actually see not only where rockets will fly over, but the International Space Station. Occasionally, when we get interesting comets in the sky, you can track that as well, and that algorithm will be put in there. But yeah, I think that's actually probably the best way to track where a rocket will be able to be seen once it's in those higher orbits.
And I do want to point out we are not sponsored by them. We are not affiliated with them. This is just a tool that we think is really, really cool. Declan, who runs it, is a good person. And certain services do cost money, but if you're really into it, it's worth it. So just mentioning, again, not sponsored, not affiliated, not being told to promote this. This is just legitimately tools that we use in the field that we find cool.
And if you've ever seen a print, hey, I had one of those too. Anytime where a rocket goes past the sun or the moon, those are usually made possible by using an application similar or that particular one, so that you know where to stand so that you can actually see the rocket passing in front of the moon.
It's yep, we've done it. There are print versions of that in the shop at shop.nasaspaceflight.com. There's plenty of amazing shots, and a lot of them take a lot of planning. That is for darn sure. Let's see here. Here's a good one from Jake again, not my Jake, although he is now lying on his side on the bed staring at me. This Jake wants to know, Trevor, how do the Starlink satellites fall out of orbit?
Yeah, so that's a good question. So once they're in that operational orbit of about 500 so odd kilometers, as we were talking about earlier, they have this gradual deorbiting process where they slowly start lowering their orbit um, to about a 250-ish kilometer circular orbit. And once they're in that orbit, they just don't do anything with them. They just let the little bit of atmosphere that is up there slowly deorbit them. So then I think once they're in that final orbit, they last there for a couple of weeks before there's enough cumulative drag for them to be brought deeper into the atmosphere and burn up. And keep in mind, the satellites burn up completely on reentry. So this is advantageous since they don't have to worry about having a bunch of debris hit the ground. They can just let the satellite deorbit wherever they want and know it's not going to cause any problems to the ground.
Yeah, that is a specific design. It is also basically a requirement now that any satellite that launches has to have a plan to either deorbit itself or deorbit within a certain amount of time, and if not able to do that, to be placed into what's known as a graveyard orbit, where there are a bunch of satellites up there that kind of just hang out. They're essentially dead, but they're out of the way of the operational satellites. And it's even not just the satellites, the second stages too. I believe that we even have the map of it. There we go. This is where they will burn up the second stage of this particular Falcon 9 flight. This one going underneath Australia, it looks like. So above the South Pole, below Australia, and the edge nearing New Zealand there. But they make sure that that happens. And we've seen it in different locations. For example, when they launch to the southeast, it's typically the burn-up zone is around South Africa. But this one, as you'll see in just a second here, is a launch to the northeast. So for those wondering today's trajectory, this is what we are looking at. Hopefully 25-ish minutes from now, you will see the rocket launch to the northeast. The first stage booster landing on, just read the instructions, about 620-ish kilometers downrange, and then that will be followed by the fairings splashing down about 700 kilometers downrange, also within that yellow polygon shape there. Thank you, Jay.
Yeah, and uh, the reason why the second stage has that reentry zone, whereas Starlink doesn't, is the second stage does not completely burn up on reentry. So there are bits of the second stage that splash down. I think, sometimes the COPVs may survive, albeit obviously very damaged, um, and bits of the engine components. So they obviously want to make sure that that debris is not hitting any marine assets in the ocean. So they just make sure that the whole area is as clear of people as possible. Where Starlink, again, just burns up all the way.
Right. Here's a unique weather question. I don't know if Julia, you want to take this. You could always pass it off to Trevor. USS Yorktown is asking, why doesn't Falcon 9 fly with the grid fins deployed? Couldn't they use that to compensate for strong winds?
Uh, I don't know the technicalities of that answer, to be honest, but my gut is telling me that having grid fins deployed would actually add drag, which would require more fuel. And Trevor, if you want to follow up on that, is my gut right?
So this is actually something that Elon discussed with Super Heavy. Since Super Heavy obviously has all of its grid fins deployed for Ascent, and he was saying that there's the trade-off is you do have a little bit more drag, although the amount of drag that is added is quite minor, since you're moving at relatively low speeds through the atmosphere, at least the thick parts of the atmosphere, on the way up. But this is compensated for the fact that you can remove a little bit of mass from the booster since you don't need all of the deploy mechanism. So on Super Heavy, they realized that it was just advantageous to have them in the deployed position, and then that also means that you are removing a moving component from the booster, and the fewer moving components, the better. So the fundamental problem with this idea, though, is the grid fins just really don't have that much control authority during ascent. During descent, the booster is moving at above the speed of sound, significantly above the speed of sound, when in the thick parts of the atmosphere. When on ascent, it's moving, they don't reach the speed of sound until a minute into flight when they're already several kilometers above sea level. So I don't think there'd be enough control authority for the grid fins to do all that much during ascent.
Now, here's a question. We'll see if you can answer it in under 2 minutes, Trevor. Your timer starts now. Does SpaceX chill the RP-1 as we near the end of RP-1 load on the second stage?
Yes, they do. So the RP1 is, I believe, just right about, it's a little bit below room temperature. So call it, a few centigrade somewhere in there, where I believe other companies let RP1 just be at room temperature. So for example, Atlas V, sometimes they'll load the RP1 onto the vehicle like days or if not weeks ahead of time, and then they just leave it there in that steady state. And then it's not until launch day that they load the liquid oxygen, obviously. So it is cooler than other companies use, but not as substantially as the liquid oxygen is.
Right, and
So
that's also... Oh, go ahead, Julia.
I was going to say, so Trevor, can I ask a might sound silly, but curiosity question? What do we define as room temperature? Because when a rocket is outside, its room is the atmosphere around it, and that atmosphere can be, I don't know, 90 degrees with a feels like temperature of 100. So what is room temperature?
I'm just using it as the temperature of the surroundings. I believe Atlas, right, especially when they load on ahead of time, they don't really care what the temperature of the RP1 on board is, whereas Falcon, they do want it to be, well, I think it's about 10 centigrade, somewhere in there.
There you go. And that is why we see them needing to have the difference of the temperature of the line between loading the RP1 and loading the liquid oxygen into that second stage. So Again, whatever your definition of room temperature, it's very different from about negative 200 degrees C. So, as a result of that, at T minus 20 minutes and 20 seconds, they have a line that needs to be chilled down ahead of it. And as a result, even though it's a chill down, we still call it the T minus 20-minute vent. And there it is, right on time. So that is a good sign that we are continuing the countdown as well. And this will go on for a total of 4 minutes and 20 seconds as they get that line prepared and ready now to transition over to loading that supercooled liquid oxygen into the second stage. And a reminder, the liquid oxygen and RP1 continue to load in the first stage as they have from the T minus 35-minute mark, both simultaneously. And you can see there, compared to yesterday's, where it kind of just hung there in the air, barely moved. You can see there's a little bit more of a breeze today as it blows, I believe that's southerly, or no, from this position that would be westerly, from our vantage point here, if I recall correctly. Julia, how are the weather conditions compared to yesterday, too? Because we can see some of it with the vent, but how does it feel? Things like that.
It does indeed feel a little bit breezier. It is also a little bit sunnier. Our sun is not exactly hidden behind a thick cloud today. The clouds we are seeing are puffy in nature, but do not seem to be endangering the launch countdown by any means. So, as far as Florida goes, as Chris B would say, it seems to be a postcard sort of day.
No, to him, a postcard sort of day would be that it's torrentially downpouring while the postcard shows the beautiful sunny beaches of Florida and all the happy people at Disney World. Apparently, that is the joke overseas that as much as we talk about sunny Florida, Florida's nickname is the Sunshine State, for that matter, that it rains more than it's sunny. Let's continue on here with some of your questions. Here's an interesting one, Trevor. Khaled wants to know, when do you reckon we'll see another satellite constellation with as many satellites in orbit as Starlink? And if I had to guess, personally, I feel like the next constellation that even has a shot at that would be Kuiper, right?
So I'll be honest, I definitely am not as knowledgeable in Kuiper as I am Starlink, but my understanding was that's going to be a smaller constellation. I don't think, at least as of right now, they have plans for as many satellites as SpaceX does. Um, so for the next constellation that has this many satellites, I would say it would probably be some Chinese um, Starlink constellation equivalent. I believe they've launched a few test satellites, but obviously nowhere near as many as SpaceX has. So that would be my guess. But uh, it's I think it's going to be very, very difficult for a lot of these companies to be able to compete with Starlink. And the reason why I say that is because SpaceX has the world's, let's face it, best launcher for these kind of missions, and they're able to charge themselves $0 for these launches and just pay for costs. So I think it's going to be difficult to compete, but that's not to say impossible, right? As New Glenn comes on, hopefully Amazon gets similar capability.
Right. I mean, those seem to be at least the big ones here in the United States. I'm sure there are others. I mean, we've seen for years that they do have them, but in the past they've been very expensive. And as mentioned before, those are at a much higher altitude, which as a result typically results in high latency. Basically, if you're trying to game, the lag makes it nearly unplayable. So, uh, the other thing that we have also is the OneWeb constellation, which again, we're talking nowhere near in the thousands, we're talking in the high hundreds, but still, that is another constellation to keep an eye on as well, in addition to, as mentioned, the Amazon Kuiper satellites, which first ones launched the protosats, as they call them, on Atlas V, and I believe the eventual goal is to move that over to Vulcan.
And you know what, Sawyer?
What?
We've been watching the building where Kuiper satellites are going to be built here on the Space Coast, being built by the SLF when we've been on flyovers, as well as watching OneWeb expanding their facilities. So I guess you never know. Maybe they'll be kind of come from behind.
True. Again, OneWeb, I believe their facility is directly across from the Blue Origin facility that is outside of KSC/Space Force property. And then, as mentioned, the Amazon one is being built up along the shuttle landing facility, now launch and landing facility, the giant runway at the Kennedy Space Center. At this point now, we are under 15 minutes away from the scheduled launch. And at this point, everything continuing to look frosty, continuing to look good, which is better than we could say we were at this time yesterday. So hopefully that's a good sign. I don't want to jinx too much more. Steve Alling saying, happy launch day. Just got my launch jump ticket for the heavy launch day. Testing jumping the camera helmet setup this weekend. Wait, so am I understanding this right that you are planning on jumping out of a plane at the same time as the Goes You Falcon heavy launch coming up?
I really hope you got that GoPro going on because that would be fun.
That would be absolutely crazy cool to see. I
That would be very cool.
Yeah, please let me know if that's true. You don't have to send it as a super chat or anything. Just tag me in that. And please, if you do get that video, tag our social teams. Our social teams would love to see that, especially because then they can pass it on to me because I know I would love to see that. So reminder to check out our social teams, by the way. We are on pretty much every major social media platform, X, Facebook, Instagram, even TikTok. We have YouTube Shorts, all of that. So, yeah. And for those asking, they're saying Goes You this weekend? Not this weekend, but coming up very, very soon, as currently scheduled for June 25th at 5:16 p.m. Eastern Daylight Saving Time from LC 39A, just a short camera pan away from where we are at this exact moment. Let's see here. It's an interesting one. Anna Perkins wants to know, Trevor, given the great investment in the Starlink program, when will it turn into profit, or has it already?
Ooh, this is a good question that I would so love to really know the answer to. Unfortunately, SpaceX does not provide us with much information on this. However, we have learned a few things. I believe Elon said at some point last year that Starlink was cash flow neutral. Um, I do not understand all of the different economic terms of how money is handled enough to know exactly what that means compared to, you know, having expenses out be equal to expenses in. Um, and then the other thing that I believe SpaceX employees have said is that uh, the each Starlink mission is now individually profitable, and what I think that means is that for each mission that they launch, the added capacity to the Starlink constellation more than pays for the launch, or more than pays for the cost of manufacturing of the satellites, and also cost of the launch. So my guess would be that we are probably nearing the point where Starlink is profitable. And Sawyer just found the tweet that I was referencing in the back channel, and that was November 2nd of last year. So it, I would say we're probably getting close to the point where Starlink is profitable.
Exactly. Again, yeah, the exact wording, as you mentioned, is that Starlink has achieved break-even cash flow. And also pointing out this was back in November of last year, that Starlink is now a majority of all active satellites and will have launched a majority of all satellites cumulatively from Earth by the end of this year, 2024. So, wow, there is that tweet. Hard to believe that was November 2nd. And here we are now, June 14th, And I'm sure, as you mentioned, that has probably increased, especially as their launch cadence is increased, and the fact that it's possible that the majority of all active satellites currently up in space will cumulatively, the ones launched from Earth, will be Starlink next year, or this year, I should say. That still blows my mind.
Yeah, it's a little crazy.
We are now coming up, by the way, on the T minus 10-minute mark until launch. So far, continuing to load propellant in there. And let's see, Steve's saying, by the way, they have two 4K Sony video cams and a Canon T7 still camera. My gosh, that is going to be fantastic. Trying to find the right word for that. uh, let's see. What other questions do we have here? Here's one from Curveless Sphere. Again, I know this is a lot of SpaceX is kind of on the quiet side with how much they release about Starlink, but any updates on direct to cell?
We've seen SpaceX has posted several updates on X about the direct-to-cell constellation. Right, they've launched quite a few missions at this point with up to 13 satellites per mission. I actually, that's a good idea. I should have a part of on my spreadsheet of number of direct-to-cell satellites launched, but I don't yet. Um, but a few weeks ago, Starlink the Starlink teams posted a video of them doing a video call over direct to cell satellites, which is very cool. And then additionally, we've seen them continually posting about, like, I believe they've sent a few posts on X through direct to cell. So they're definitely making progress. I believe John Edwards and other Starlink representatives have noted that their goal is to be operational by the end of the year with the direct to cell constellation. It's not exactly clear to me what they mean by operational, since they plan on continuing to launch a lot of these direct to cell satellites. It's probably some minimum viable product that's only on certain sections of the Earth's surface, if I had to guess. But they've been making great progress, and frankly, it is absurd how quickly direct to cell went from an announcement with T-Mobile to being a thing that's actually working in orbit.
Exactly. And hopefully we'll see more of those eventually starting to launch from the Cape. Right now, as you mentioned, launching out of Vandenberg Space Force Base out in California. We are now under 8 minutes away. Julia, do you mind giving us a final weather check before we let you go to set your cameras up?
Final weather check is nothing has changed since the last weather check. It is still puffy clouds, sunshine, and, I think good to go weather for a launch.
That is what we're hoping we see, as you mentioned before, those just light puffy clouds. So we will let you get your camera set up. We will talk with you after the launch. All right, we are now at the T minus 7-minute mark, which at this point they will begin chilling down those 9 Merlin 1D engines. Simple question for you, Trevor. Why?
Why chill?
Why
That is a-
chill? I mean, well, I know why I chill, but why the engines?
They just want to relax, they're going to be stressed out soon. No, in all seriousness, um, the reason that they chill the engines is they want to cool them down. As Julia was mentioning earlier, right, the air out there is on the order of 90 degrees Fahrenheit at this point, which is 30-ish centigrade. And this has the problem that uh, liquid oxygen is very cold, right, about negative 200 degrees centigrade. So what would happen if they started running liquid oxygen through the engines at T0 is the liquid oxygen would just hit that warm engine and immediately boil off into a gas, which would cause substantial damage to the engine and would lead to what's known as a hard start, which could, in extreme cases, could lead to the engine destroying itself. So to prevent this, since rockets generally prefer to not destroy their engines, um, they run a little bit of liquid oxygen through the turbo machinery of each of the 9 Merlins on the first stage. And this just helps cool them down so that when that propellant starts flowing at T minus 2.5 seconds, give or take, they'll be able to ignite the engines without the engines having a hard start.
Yeah, hard starts are bad in this case. We do want to hear engine start, though, at least, so hopefully we'll get to that in about 5 minutes from now. So now we're going to get into the busy portion of the countdown here. For those just joining, as we near those 5 minutes until launch, this is a Falcon 9 rocket on the Starlink 10-2 mission, carrying 22 Starlink V2 mini satellites into low Earth orbit. The booster for this flight is booster B1063 or 73, excuse me. And this is its 16th flight. Once it lifts off to the northeast, the booster is expected to land on the drone ship. Just read the instructions. About 600 kilometers, again, as mentioned, to the northeast for this flight. Now at T-minus 4.5 minutes, we should see the retract of the strongback. And that is the metal structure that is next to Falcon 9. It sort of unclamps from underneath the fairing and leans back 1.8 degrees. Trevor, can you kind of explain why only 1.8 degrees?
Yeah, so Slick 40 has the new throwback style tee, and I say new in quotes since it's been around for the better part of a decade at this point. And what this does is, as Sawyer mentioned, that right on your screen right now, you can kind of see the tee just to the left of the fairing. That will retract by 1.8 degrees, which will just put it in its launch position. And then the TE will stay there until the vehicle lifts off, and then it will throw all the way back after liftoff to over 45 degrees away from the vehicle. And what that ensures is that the TE is as far away from the exhaust as possible, which means that it has very little refurbishment needed between launches. And right, this is how the TE works both at Slick 40 and also LC39A, but this is not how it works at Slick 4 East at Vandenberg. Vandenberg has the older TE design where it does not have that throwback maneuver that I was mentioning.
And as you heard from the net there, that the retract is complete, as mentioned, to that 1.8 degree mark for now. We should be getting calls now as they finish up loading the liquid oxygen on the second stage, as well as the RP1 unlocks on the first stage. So we should be hearing those callouts within the next couple of minutes here. And then at about T-minus 90 seconds.
Locks load complete.
There we go. Liquid oxygen fully loaded on that first stage. We should see a big vent coming at T-minus 90 seconds, which will be following the completion of the liquid oxygen load onto the second stage. In that same line where we saw the LOX chill down, we will see a purge of any remaining liquid oxygen that may be in those lines so that it doesn't accidentally ignite as giant balls of fire pass next to it as the Merlins lift off. Coming up now on 2 minutes until the scheduled launch time here. The big milestones that will be coming up are at T-minus 1 minute. That is when they will pressurize all of the tanks to flight pressure. That is also when Falcon 9 enters startup.
Locks load complete.
There we go. Stage 2 LOX loaded complete. Keep an eye out for that line purge, and there it is. See it on the right side of the tower there. And once Falcon 9 enters startup at 1 minute, that is when the onboard computers will take control of the majority of the countdown at that point.
Gas
The next
launch
thing after
closeout.
that we will hope for a go for launch at approximately T-minus 45 seconds. The excitement starts to build at this point, I'm sure you can tell. And the callouts from SpaceX Stream may be a couple seconds behind what we're actually seeing on our cameras here because of the latency of their broadcast. We are now under 1 minute, so Falcon 9 should be in startup. And there we go, there's the confirmation of that. In another 15 seconds, we should hopefully get that go for launch.
The go for launch.
There it is. We have the go for launch. We're now 30 seconds away from the liftoff of Starlink 10-2. Now, I know I'm talking a lot, and I know a lot of people aren't fans of that. I promise that we will be quiet during the actual launch portion itself. Just keep in mind, it will be quiet for a little bit, as it takes some time for the sound to reach our microphones at the press site, about 3 miles away. Under 10 seconds to go. We should hopefully see the rainbirds with the deluge water at the base of the rocket, followed by ignition. And appears we had a cutoff. A rare pad abort.
Yeah, that is not what we were hoping to see today, but the vehicle at least appears to be in good health, so let's stand by for any words from SpaceX.
Yep.
The poor rocket said, well, the weather's okay, but nope.
Again, we're continuing to listen in to see if there are any updates from SpaceX on the nets that they make public. And a reminder for this one, for shuttle, this was known as RSLS, where you actually had the engines ignite, but it was then called off prior to launch here. This isn't the first time Falcon 9 has done this. I have personally been at launches that have done it at T-minus 2 seconds, and one that did it at T-minus 0.5 seconds. And that in the bottom left of your screen is the depress vent that we're kind of seeing here, so that will likely mean a scrub, as you can see in the corner of our screen there, for the day. Yep, with drain back ongoing, that means they will begin the process of offloading fuel. Well, this is quite unusual. That's why I'm a bit silent here as we were trying to listen in and figure out what's going on. As mentioned, it has happened in Falcon 9's history, but it has been quite a while. And to the people in our back channel, please stop saying West Coast, Best Coast. Just because we had one scrub, at least we could see it scrub.
Ooh, ouch.
I
East
don't
Coast,
know.
West Coast.
Agreed, Julia. East Coast, Best Coast. But at this point, I don't know if anyone in the back channel was able to see what the exact abort time was or when the clock stopped on the SpaceX feed. So just want to keep an eye out for that. Reminder, though, we are not done live streaming today. In fact, we are about ready to head on over to the Flame Trench. And while it may not be safe to enter the real Flame Trench at this point, Flame Trench is our Friday show where we're on camera talking about the news of the week in a more kind of loosey-goosey fun environment, as well as the ability to take your questions. So just make sure you check that out coming up pretty much immediately after we wrap up here. And at this point, we don't know the exact time as the clock did not stop. Let's see here. Oh boy.
I'd say I would offer like a metal print of this launch, but to be fair, I've set up twice. And I've seen an awesome sunset yesterday. The metal print I would be able to offer from this launch campaign, shall we say, actually would be kind of pretty. It was a reflection shot of a very Space Coast view. But I'm going to hold that, hoping one of these times I'll actually catch that with a rocket streaking through said picturesque frame.
Yeah. Again, an RSLS abort as it used to be known during the shuttle days, which, speaking of shuttle, don't forget, if you do love shuttle as much as we do, we have our Shuttle Sundays on Space Coast Live every Sunday, 3 p.m. Eastern, 2 p.m. Central. That is usually Chris B. and myself, and sometimes Jack, talking about the awesomeness that has been the Space Shuttle program. So we've gone through, you can rewatch some of the old episodes already of including the first flight, the first operational flights, the first flight of Challenger. We have the first woman in space, the first African American in space, the first concerns of foam and heat shield tile damage in space as well. And then coming up, we have, I would say we have STS-10 and STS-11, but technically we don't, because they changed the names to STS-41B and 41C, both flown by Challenger. Why? Well, you'll have to tune in and we'll talk all about the stupidity that was the naming program all the way up until the end of the 25th shuttle launch. So all of that still to come. Again, also still to come, the flame trench. What was that, Julia?
Sawyer, I think that's a trend across multiple programs naming. Unexplainable naming like programs, because I have gone through my hard drive and I know toward the beginning of Starlinks, my naming system is literally Falcon 9 V1 Starlink like 2, and there's nothing consistent from then till now.
Yeah, good point. What, like say randomly changing the Starlink shell to a 10 after everything has been an 8? Just saying. We had 8-5, then 10-1 and 10-2, and it's hard to tell sometimes what the main difference is between all of them.
Now imagine going down to port and wondering what it is you're going to put on your board, because maybe the last launch it was a 9, now we're an 8, and then it's a 10. So not confused at all. And I believe there was in the last, the last series of Starlinks, there was a number entirely missing. They never launched that number. And I think it was a 50, maybe it was 52. I don't remember, but there's literally a number missing in the whole sequence.
Yeah, that is very true. Well, yeah. So unfortunately, a scrub. I do want to note on the SpaceX website, it did say that they do have another attempt opportunity available starting tomorrow at 4:07 p.m. Eastern Time. However, that may take a little bit longer depending on the exact reason for said abort. So keep an eye on all of our social channels as well, and we'll update you on when that next stream is based off of when that next launch date is, pending the results of this on-pad abort. But once again, I want to thank the people that came out and got under the T-minus 30-minute mark, and now we've seen 2 scrubs. Julia, thank you for rolling out yesterday and today.
It was a blast, and I'm sure the party will continue on as we roll out of Starlink mode.
A blast is what we got, but not a blast off. Thank you, Julia. Trevor, thank you as well for joining.
Yeah, of course. Let's continue hoping this mission eventually gets off the ground.
Exactly. And in the field with the cameras there was D, who you will see momentarily on the flame trench. It may be slightly warm still, but don't forget, that is coming up next. You'll see me on there again as well. I am Sawyer Rosenstein. I've been your host here. And of course, I have to give a huge thank you to Jay Keegan in the background for pushing the buttons, pulling the levers, and making my crazy requests in the back channel appear on screen. So thank you for that. In case there wasn't enough chaos, Kevin Michael Reed is up next on the behind the scenes portion for the Flame Trench. We will see you over there. There's already a countdown underway, so we'll take you over there after, of course, we roll the outro. Have a great day, everybody, and we'll see you for the next attempt.
And here we go.
Propulsion continues to be
chamber pressure looks good.
Following up. Roger, roll, planet.
Water towers, fly! Yes! Tango down to nominal.
Flight downside FTE off. Say again, FTE off. Off. It's orange!
Oh my god! Oh my god!
Décollage.
Look at this!
Put that in the big bag, Jingle.
343 unfolds to go.
Indeed. We rise together, back to the moon and beyond.
This methane will be igniting the flare, correct?
Yikes. You dead? Sure. We don't need any more of these.